Welcome back to Jackson Square. Today we're still looking at TEK 6.10a, which says I can model and solve one variable, one-step equations and inequalities that represent problems, including geometric concepts. We've already looked at solving one-step addition and subtraction problems, so today we're looking at multiplication and division. Things to remember. Please remember our yellow circle or square represents positive, our red is negative, a green rectangle is positive, a red is negative. Cups represent our variable of X or Y or Z or B as well. And remember, when they are together, yellow and red, they make a zero pair, or green and red, they make a zero pair. So we had an example of a multiplication one on yesterday. So we're just going to jump right in with what we remember. So here it says 3p. So that means I'm going to represent that with 3 cups. And then it says equals 18. So I need 18 positive counters or yellow counters. So I'm going to do my trick of copying these and then pasting them. Pasting them again because it's just so much quicker. So then I have 3p equals 18. So remember, this is 3 and the p are being multiplied together. So we are going to do the inverse of multiplication, which is division. So I need to take those 18 counters and go 1 for you, 1 for you, 1 for you, 1 for you, 1 for you. I'm evenly dividing them among these 3 cups until I'm done. And then when I'm done, I'm going to look in that cup and count how many counters are in each one. Well, as you can see, I already kind of divided my counters up into groups of 3. So 1x or 1p in this instance, p would represent 1, 2, 3, 4, 5, 6, would be a positive 6. P would equal 6. And we can go back later and do the side work for that. I just want to go through and do the video part of the modeling first, okay? So if you have any questions about that, please ask. So here we have 4x equals 8. So I'm going to represent this time with algebra tiles, and I'm going to do 4 green bars. And then I'm going to put 8 counters. Okay, so again, while I'm taking these 8 counters, I'm going to do the opposite of multiplication, division, and I'm going to split them up among the bars. And if I did that, then each one of these bars would have 2 yellow counters. So the value of X would be 2. And we can check that. We know that 4 times 2 is 8. So that makes sense. So I'm just going to take this problem from last time and see if I can tweak it really quick for this one. So here we would have 4x is equal to 8. Remember, we are dividing, okay? So we're going to divide both sides by 4. We're not doing the opposite number. We're doing the opposite operation. So I need to grab a line to represent my fraction bar. I'm going to draw on each side. Sorry, those are not straight. So I'm going to divide both sides by 4. And I'll move my 4 over so it's a little bit better. And then 4 divided by 4 would leave me with just 1x. And then 8 divided by 4 would leave me with 2. And of course, the first thing I was supposed to do, shame, 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 is do my dotted line. Okay, so remember, we always want to create that dotted line, and my line is crooked because my equation is crooked. You want to create that dotted line to represent your dividing that problem into two equal sides. Remember, equation is about balance. You want to keep it balanced. Whatever I do to one side, I want to do to the other. So this is what the work on your paper would look like. So now we want to look at an example of division. Multiplication is pretty easy, kind of straightforward. Division is a little bit more difficult to model. So I'm going to just show you this model, and then we're going to talk about how the problem would look numerically. So here this is t divided by 4, which equals 4. So t divided by 4, we never really use that. I always make you bring out that fraction. So this problem is really 1/4 of t, or 1/4 times t equals 4. So what does that look like if we were modeling? So if I had a cup, I would break my cup into fourths. What is 1/4 of t? Well, we don't know what t is, but it's represented by the cup. So what's a fourth of that? So I broke this into fourths. And then it said 1/4 of t equals 4. So I drew that this one section, 1 out of 4, represents 4 counters. Well, then if I wanted to know what the whole of t is, because right now we're only looking at 1/4, if I want to know what one whole t would represent, I would break for each 1/4, I would get 4 counters. So then the answer would be 16. So the whole value of t would be 16, if that makes any sense. So if you imagine each one of these sections is 4 counters, if I had arrows on all of these, and it would equal, the whole cup would equal 16. So what would that look like with us doing it with numbers? So with us doing it with numbers, I'm going to drag this here. Here's my problem. And this time I am not going to forget. I'm going to create my dotted line. I just hope everything lines up. Okay, so create my dotted line for my sides. So first we have t divided by 4 equals 4. I always have you guys bring out that fraction so you can see, hey, this is definitely division because I see that fraction more. So t divided by 4 is really 1/4 times t. So we're going to pull out that fraction part. And then we have to do the opposite of division, okay? So the opposite of division is multiplication. And that makes so much sense because this is a fraction, right? Right? And we don't divide fractions. What do? Multiply by the reciprocal. So here we want to remember that having the reciprocal is very important. We want to multiply by the reciprocal. And I thought I put it on this page, but I didn't. I put it here. So I'm going to copy this and stick it back here on this page. We want to remember reciprocals, okay? Whenever we're talking about fractions and dividing fractions, which we don't do, we multiply by the reciprocal. That is what we're doing here. We're multiplying by the reciprocal. So we want to get rid of this 1/4 because t wants to be a what? Alone. We want to isolate and solve for the variable. Isolate and solve for the variable. Isolate and solve for the variable. So t wants to be left alone. Who's on this side with t? 1/4. How do we get rid of it? By multiplying by the reciprocal. So we're going to multiply both sides by the reciprocal because remember, we have to keep this thing balanced. So we're going to multiply both sides by the reciprocal. I'm trying to line that equation up. So the reciprocal of 1/4 is 4/1. So I multiply the left by 4/1 and the right by 4/1. Okay. So what does that look like in, let's say, I guess, extended form? So 4/1 times 1/4 is 4 times 1, which gives me will give me 4, and then 1 times 4, which will give me 4, and 4/4 is just 1. So I would end up with 1t on this side, and then here, remember this 4 is over an imaginary 1. You make it a fraction by putting it over 1. So we have 4/1 times 4/1, okay? And we'll multiply those across. On this side, this 1 will disappear. Remember, it's invisible, and we'll just be left with t. And then on this side, 4 times 4 will give us 16/1, and you can remove the 1, and we'll just have 16, which is true of our picture, right? I told you that if we duplicated that fourth, we would get 16. So this is how the work would look. I know that's a lot. Take it in, but it's going to just really help you. You're not going to have to write all of this extra stuff, but I wanted to demonstrate it on the first one so you guys aren't like, well, what happened to the numbers and when you multiply by the reciprocal. So when you multiply by the reciprocal, you end up getting one whole. The one's invisible, you're just left with t equals 16. So let's try another one. So here we have 5 is equal to d over 8. Remember, it doesn't matter if the variable's on the left or the right. That's insignificant. You're still going to balance both sides. So the first thing we want to do is definitely drag out that fraction. And I keep forgetting because I'm not doing this with paper and pencil. If I had paper and pencil, I would be on it. But I need to make sure I'm creating that. So I have to lead by example, right? So I need to create that dotted line so we have that balance. And I'm going to pull out that fraction. So d divided by 8 is actually 1/8 of d. Okay, so 1/8 of d. I see that that is a fraction bar. That's division. I want to do the opposite of division, which is multiplication. So to get d alone, because he wants to be isolated, he wants to be alone, you have to multiply both sides by the reciprocal of 1/8, which is 8 over 1. So here in our next step, you see 8 over 1 times 5 is equal to 1/8 d times 8 over 1. Again, if I multiply these together, 1 times 8 is 8. 8 times 1 is 8. 8 over 8 is just 1. So then in my next step, you see I just simplified that down to 1d. And then here I've made the 5 into a fraction, putting it over 1. And then 8 times 5 will give us 40. And then so d equals 40. That is our value of d. If you have any questions, ask me, stop me now. Ask those questions that you have. If you don't have any questions, here's one for you. So write this one down, practice, and get back with me, and we'll go over the answer. Good luck.